See, produce. Produce is just adding the values to the list. Similarly, consume also we have while loop, infinite while loop, and synchronize of this on the current object synchronizing. If list or size equal to 0, we'll go to the wait state. And here what we are doing is list dot remove first. We are just removing the values. Consumer means just removing the values and printing the value. After that we are notifying, calling the thread dot sleep. Now producer always produce the data. Producer is adding the data to the list. Consumer is always removing the data from the list. Producer means who is giving the data. And consumer means always taking the data. But producer at some time period. A producer can able to produce only two values. If the capacity is equal to 2, then he has to stop producing the data and ask consumer to remove the data, means reading the data. Now here, the producer list size equal to capacity. Okay, if it is reaching the maximum capacity, then he will go to the wait state. Wait state means on top of the producer consumer PC object, we are calling wait method. If we call wait method, it's always go to the waiting state until someone has to call the notify method on the same object. Now this will go to the waiting state until consumer has to read the data from the list. Reading means removing the data. Then once he remove the data, he will call the notify method. Once he call the notify method, then again producer can able to add the data. This is infinite loop. Now we have one problem in case of the infinite loop. That is one important interview question. Let's go and see that. Now here, what is producer consumer? Producer always producing the data until he reach the maximum capacity. Here consumer always removing the data until the capacity will become 0. Up to 0, he will remove the data. If it is 0, then he will go to the waiting state. He will go to the waiting state. Then again producer will take action. He will go and add the data up to capacity increase of 2. Now here, what is the problem when we use the infinite loops? Let's go and see. I just put in the readme. The main question is what is polling and what are the problems with it? See, if you use infinite loop, we'll get the problem of polling. The process of testing a condition repeatedly till it becomes true is known as polling. Now we are seeing the program 2. What is polling? The process of testing the condition until it becomes the true. Here we are just doing the process until list or size equal to capacity. If it is becoming true, then we will go and call the wait method. So this producer is doing one process until the condition becomes the true. If the list or size equal to capacity, here if you give size of capacity equal to 200, if the list size is becoming up to 200, it's always keep on adding the data. This is called polling. The process of doing one activity until the condition becomes true. So that process we can call as a polling. This is called polling. Now, how to Here we have seen the what is polling. Then here we have to see what is inter-thread communication. Now here in our program tree, I'm creating two threads in the main method. Inside the main method, I have created the object of the producer consumer class, PC class. I have created two thread objects, thread T1, thread T2. Now this is a one more class. Now we have seen the inner class, static inner class. Now here the concept of anonymous inner class. See, inner class has a type of the class which we can create inside the class. That is called inner class. Here the class is a static inside the class. So the classes we can call as a static inner class. What is anonymous inner class? The class is having any name. The class is not having any name. Subclass any other class. Now here I am creating subclass of thread class. See, we cannot create the thread class directly. We have to create a class E extends of thread. So E is a subclass of the thread class. Now here anonymous inner class is not having any name, but we can directly create object to the anonymous inner class. This is a way of creating an object to the anonymous inner class. This is not having any name. New thread of new runnable. Inside the runnable, we are just overriding run method. Anonymous inner class is not having any name, but we can directly create object to the anonymous inner class. So here I am not doing any creating any name to the anonymous inner class, but I am directly creating object to the anonymous inner class and assigning to the variable thread T1. This is called anonymous inner class. That much we remember now. You can see the inner classes on next classes, next sessions. Now I created two objects, two anonymous inner classes objects. Now this is anonymous inner class which have the argument as a new runnable type. Runnable type is overriding run method. Inside run method, I'm calling pc.produce method. Whenever we call produce method of PC class, inside the produce method of PC class, we have one synchronization block. By taking the block of producer consumer, it will go and execute this until the condition will become true. Then it will call the wait method. Now, to, under, to achieve the inter-thread communication, we have to learn three methods. Three methods are very important when we learn the inter-thread communication. Wait method, notify method, notify all method. What is the each and every method? All these methods are coming from the object class. All the methods are available in the object class. We are just will get that methods overridden to our class by default. Wait method, notify all method. All the methods is available in each and every class because object class is a supermost class for each and every class, directly or indirectly. Now, what is wait method? Now, whenever we call wait method on any object, Whenever we call wait method on any object, here if you see, we call wait method on this object. Here one more thing, we have to call the wait and notify all methods for thread safe objects, for thread safe blocks. Inside synchronization block only, we have to call the wait and notify all methods. We should call wait, notify all methods inside the synchronization blocks. If you call wait method on any object, we are telling JVM, don't execute the current thread on which thread we are calling wait method. Just stop executing until somebody has to call notify all method on the same object block. If you call wait method on any object, we are just telling to the thread, don't execute the remaining portion of the thread until somebody has to notify, notifying you has to complete the remaining portion of your execution. Now here, for example, producer we have consumer. Producer is just giving the data to the linked list, adding the data to the linked list. We are just adding the data to the linked list up to capacity 2. If the condition is true, it will go to the waiting state because we can't afford to add more data to the linked list because the capacity is reached. So you will go to the waiting state. Wait state means is keep on waiting for consumer has to take the data and notify back. Once the consumer is notifying back, then he will go ahead and add the other data. That is called wait method. Now notify method. Notify method means if somebody is waiting, now producer is waiting because its capacity is 2. Now consumer is reading the data. He has read the data and the capacity becomes 0. So consumer will notify the producer, just go and add the remaining data. Notify method is for notifying the thread. I just read all the data, just continue adding your data again back. That is notify. If multiple threads are in waiting state, if you want to notify them to continue their work, you can use notify all method. All the threads which all are in waiting state, they will come out and they will continue their execution. If you call notify method on the object block. Now here we have 2 threads. 2 threads are using the same resource, producer consumer object. Now, if first thread is calling produce method, if the capacity is increased equal to 2, then it will go to the waiting state. Until consumer has to call notify method, he won't come back and continue with this execution. That is called wait method. He will go to waiting state. Then if you call notify method, so we are just notifying the consumer, just continue reading the data, continue reading the data. Whenever it is calling notify method, consumer is calling notify method, it will go and continue the adding the data. And let's go and run this. Now producer produced 0, producer produced 1. Then consumer is reading the data 0 and 1. Producer again producing the 2 and 3. Consumer is reading 2 and 3. Similarly, you see here, first producer is producing two data because the capacity is 2. This is infinite loop because while true. Let's keep on going. It won't end until we have to end. I'm just calling end. You go and see here. First producer is producing 2 data. Now how it is executing, you can see. First main method will execute. Inside the main method, object is created for the PC class. Now here we created object to the thread classes, P1, P2. And after that, I'm calling start method. Whenever we call start method, run method of a T1 and run method of a T2 will start. Now run method of a T1 is calling the PC.produce method. Now run method of a T2 is calling PC.consume method. PC.produce method, what it will do? When it is executing PC.produce method, the value is 0. And while true, we have synchronization block. If the list is 0 by default, 0 equal to capacity, it won't go here. Then we go on to produce the data, value equal to 0. Then adding that value, list dot add of 0. Now value is becoming 1 because value plus plus. Then calling notify because this consumer also reading the data. Calling wait and notify on the producer, calling wait and notify on the consumer. So both will wait for some time. The capacity is equal to 0, then it will notify them. Now I want to stop the notifying the consumer to consume. Then it won't go to next position. It will stop there. After producer 0, consumer is consuming the 0. Producer 1 and producer 2. After that, we are not notifying the consumer to read the data. Then it stopped. If we want to achieve producer consumer, we have to call wait and notify methods. To call wait and notify methods, producer will produce the data, consumer will consume the data. This is a little bit confusion. Just have to remember what is happening there. Now, producer always keep on producing the data until the capacity becomes the 2. Consumer always consuming the data until the capacity list of size is becoming 0. This is called producer consumer problem. It will go infinite, so I am starting this. This is one example of producer consumer. Let's go and see. See how the polling problem handles in the multi-threading. To avoid the polling, we have to use the wait, notify all methods. The process of testing a condition repeatedly till it becomes true is known as polling. How to avoid that? How to handle that polling? To handle that polling, to avoid the polling, Java uses 3 methods, namely wait and notify all methods. All these methods belongs to the object class. All the methods are final methods. So that all classes, whatever classes directly or indirectly subclass to the object class. So we'll get all these methods to our class. Now what is wait method? It tells to the calling thread to give up the lock. It is just telling to the calling thread on which thread we are calling wait method, give the lock and go to the sleep until someone has to call the notify method on you. If it is calling wait method, it should give the lock and go to the sleep until somebody has to call the notify method. What is notify method? When we call the notify method on the method, it will wake up, take the lock, it will continue its execution until somebody has to call the wait method on the same object. If you want to wake up all the threads which is called by the wait method, you have to use the notify all method. This is about wait, notify all. Now let's go and see next example. Yeah, this is a little bit big example. We'll see. I'll explain this. The, the next class. Now here we have some other concepts. Now what is the, this is one more interview question. What is the purpose of start method? Why we need to call start method? We have a thread class, creating object to the thread class. Here we are calling thread dot start method. Why we need to call start method? See, as we said, whenever we call start method on any thread, it's just creating a new call stack of a thread. New call stack is created for the thread. and then it is running the run method. The creating the call stack and running the run method of a thread is happening by the JVM. JVM will take care of creating new call stack for the thread T and calling the run method internally, the call start method. I am directly calling the run method of a thread 3. Thread 3 extends of thread overriding the run method. Insert a run method, calling the name of the thread is running. Which thread is running I am calling. Printing. Now program 5. We have a main method. Inside main method we have for loop. I equal to 0, I less than 10, I plus plus. Creating object to the thread class, calling the run method. Whenever we call this, we'll get 10 times main is running. When we call run method, it is not creating a new thread class. It is not JVM is not creating new call stack and it's not calling the run method of a thread 3. Just calling the main thread only. Now if we call this, we'll get only one output. Main is running. Now if we call start method, whenever we call start method, the main thread activity will happen. The thread object is created, new thread object is created. For that thread, name is assigned and ID is assigned, and it is calling the run method of the new thread. Whenever we call start method, then only lifecycle of a thread will start. Now let's go and run this. Here if you see, multiple threads objects are created when we call the start method. It means like if we call start method, then only thread lifecycle will start. New thread objects will create. If you simply call the run method, it's always thinking it is a main thread only. We will get same thread, main thread only. So whenever we create a thread class, we have to call the start method, because when we call the start method, the main activity will happen. Object is created to the thread. The name also assigned to the thread class. New name for every thread. Here, if you see, new name is assigned. New ID also assigned for the child threads. So this is a way of creating the start method. Then what is the purpose of start method is the separate call stack is created by it when we call the start method, and the run method is called by the JVM. JVM will call the run method of separate thread. Now what is the next program? We have only two concepts. Just wait for 2 minutes. I'll come on. I'll explain again. We'll complete this. Before that, if you have any doubts, you can ask. Now, what is the next topic? Now, in the multi-threading, next one is thread pool. What is thread pool in Java? Thread pool is pool of threads. See, by default we just create some threads and putting the threads into the pool. Whenever we want, we can use that thread to execute our task. Once our task is completed, then we will release the thread object. The thread object again it will go and sit in the thread pool. For example, thread pool is a list of thread objects. Thread objects is inside the list. Now, if you have 10 tasks, we will take 10 thread objects. We can execute our tasks. After your task is completed, again you will giving back the thread object to the list of objects. Now, for example, in our thread pool, we have 20 thread objects. We have 10 tasks. We'll take 10 objects and complete our task completion. 10 objects will take and execute our 10 tasks. Once the 10 tasks are completed, it will giving back the thread object to the thread pool. Now, available thread objects in the thread pool is after completion of all the tasks, 20 objects again. Now here, we have 20 tasks, for example. All 20 objects it will take. If we have 21st task came to our thread pool, it will wait for some other thread has to complete its tasks and assigning back that object to the thread pool. Then once it is assigning back that object to the thread pool, then only the 21st task will take and execute it. Now this is called the thread pool is reusing the previously created threads to execute our task. Thread pool is we just create some objects. We can reuse that objects how many number of times we want. By default in Java, we have executor service, which will help us to create pool of threads. We have a executors dot new fixed thread pool. We call this method and passing some number. That many objects it will create for us. If we want to execute our multiple tasks, we can execute that multiple task using this thread pool. Java will support by default thread pool by using the executor service. If you want, you can read this and understand what is happening. Same thing I will explain. Executor service is by default provided by the java.util.concurrent package. By using this executor service object, we can execute any number of tasks. These are we have 5 tasks in the main method. Task is the first task, second task, third task, fourth task, fifth task. All the tasks are runnable type. Now I have created a thread pool of size 3. Now my thread pool size is 3. Maximum t equal to 3 I am passing to the new fixed thread pool. Now our thread pool is created with the size of 3. Now when we call pool.execute method, it will execute the all tasks. But here our thread pool size is 3. So first 3 tasks will execute first. Once the 3 task is completed, then next task will pick up and execute that. So if you want to give the maximum size of thread pool is 20, you can give it here based on our requirement. Now after completion of our execution, if you want to shut down our pool, if you want to clear our thread pool, we can call pool.shutdown method. This will take care of clearing all our thread objects in the pool. This method will take care of providing the thread objects, multiple thread objects for us. Now inside a main method, we have 5 objects, 5 tasks, 5 threads. Runnable means thread only. Create 5 tasks. All the tasks we are executing using thread pool of size 3. So first 3 tasks will execute first, then remaining tasks will continue executing. Now what is there inside the task? We can see class task implements of runnable. Inside the task I have variable private string name. I am just initializing the variable using the construct of the task. Inside run method, we have try block and catch block. Int I equal to 0, I less than or equal to 5, I plus plus. If I equal to 0, see to take the date of current date. If you want to get the current date, we have date class. This is from the java.util. By using java.util.date, we can create current date. How to get the current date, hours, minutes, and seconds? We have simple date formatter. This is from the java.text.simpleDate formatter. By using the simple date format, we can get the date into hours, minutes, and seconds. Now here in system.println, initializing time for the task name, the name of the task I am printing, then how to print the date and time in the format of hours, minutes, and seconds. The formatter.format to pass the date as an argument. The formatter.format will take care of printing our date for us. Similarly, if I equal to 0, we'll do this one. If I equal to not 0, then we are doing this. Same thing. Date formatter we are printing. Executing time for the task name. First one is I equal to 0 means initializing the time for the task name. Executing time for the task name. We are just printing the executing time of current time. And I am calling thread.sleep of 1000. And at the end of the try block, I am just printing the name of the task and just adding completed. Now this is simple. Thread pool is pool of threads we are creating and using that for the execution of our task. Now we have only 3 tasks. We can execute only 3 tasks because our thread pool size is 3. First, if we see, first we have our thread pool size is 3. So it is taking the first 3 tasks. All the 3 tasks executing time of the 3 tasks is this much. Now the time is 3:30:57. So this is the timing we are printing for the executing time. Then after that, all the 3 tasks are completed. Once the tasks are completed, then the thread objects are becoming free in the pool. So next tasks, whatever tasks are in the queue, those tasks will take and executed. Now other 2 tasks, 4 and 5 are initializing first, then executing. This is executing time of the task. After that, it's completed. Now, similarly, if you want our thread pool size is 5. Now the size of the thread pool is 5. So all the tasks will execute at a time. First, all 5 tasks are initializing first. And all the tasks are executing. All tasks are completing. See. Now if you want to make a thread pool size is 2. Now first 2 tasks will complete. Then see, first task 1, task 2 will complete. Then other tasks, after the first and 2, task 3, task 4 will start. At the end, task 5 will start. Classified is completed. Here we just remember executor service will take care of that pull. Yeah, this is about thread pull. Let's go to the next example. Now, next concept is what is deadlock. This is also very important for the interview. We can see the deadlock in the tomorrow class only. Because today, if you tell everything, it will become confusion. We'll focus on and we can start collection API tomorrow.